the first thing is I've acquired some seeds and kind of gained a little bit of hindsight knowledge about what it would take to use robots to reach a post-scarcity food economy. So a lot of these seeds, they're all organic and they're sourced from Fedco and Adaptive. I also bought some flower seeds, and the interesting thing is I've been able to, so let's start with here, is like I was able to get free historical soil temperature and moisture data, and then plot this out. Okay, so if we measure this is from a station, a soil monitoring station called Sleeping Woman, that is the closest to where I will be growing my food. And you can see there's basically different soil moisture and temperature, and right now we are at a place where the soil moisture is pretty much the highest it will ever be. It'll go up a little bit more, and then it will fall down to nearly zero by the end of the summer. But soil temps are really just start creeping up, and it really won't be able to be plantable for anything reasonable until the end of May, which means there's a really short and challenging growing season. And so this stuff was motivated by this needs to be modified, but the basic idea is I've been exploring this idea of using a large language model to source seeds by using a web browser. In this case, I'm using Selenium and Python. It's kind of primitive, but it could really use a video pre-training or a visual multimodal aspect. But the basic idea is that the dojo could have some sort of budget, right, or be generating income autonomously, and then it can just kind of make its own decisions about what plants would be best based on observations of the environment. And so there's a lot of potential hardware paths to do this. One interesting idea is wow, okay, I'm going to be a little bit more careful. Yeah, so one thing I've also been exploring is, the National Agricultural Library API. You could get some amount of data from this without measuring. It would be nice to have direct caloric sensors and stuff, but it is what it is. Okay, so one of the purposes of Robot Dojo is to kind of expand some testing that I did at Open Source Ecology on a remote controlled tractor, and then kind of some of the things I realized are to have like a permaculture system. You might not want a tractor, you might want something more like a hexapod or some sort of more creative, basically, or agile robot. And then you gotta open source this stuff. So Zenta is like basically one of the coolest robot builders in the world, and you can see like he's built some really amazing hexapods, and Morphex is a good example because it can roll into a ball, and I think that's a very interesting design. So I'm gonna be basing my robots off of Zenta's work. In addition, I'm going to be getting into RISC-V to build the core AI of the dojo. I've mainly been using like NVIDIA GPUs and all that sort of stuff, but I really think that if I want to be more energy efficient, and you think about what it would take to get AI embedded onto like a robot, you have to start being more creative and energy efficient. And at least for the dojo's core, something like Orange Crab is going to be what I'm going to try and use here, as it will kind of push me to see what I can do on a very edge device. So I have a Voron 2.4 they're going to be using to help me make these robots, but I'm not going to have it until the end of June, and so it's gonna these robots aren't going to come online till the growing season's almost over. That's just kind of the reality of the situation. But some ideas around this are I'm planning to use an ESP32 chip, just like I did at Open Source Ecology. Basically set up a camera and have it, moving around, doing some segmentation of the environment. Maybe set up a simple large language model that's streaming and parsing through the segmentation data. Another idea is you can have basically a real-time neural radiance field that you'll be able to interact with, like it's a game or something, for planning, as well as for basically parsing through the memories of the robot. It only makes sense to store some things, so it's probably not going to be this high resolution because it's always going to be a trade-off. But I'd like to explore how far you can push nerfs in terms of creating a game-like environment for automating food production with robots. And finally, there's this paper called Concept Fusion, which is basically integrating things like audio and point click queries. So the idea is you can use audio and image queries or things like that in order to search through a visual nerf or even something that's temporal. In terms of Dojo design, so far I've been doing various experiments with the vacuum insulated panel, and in terms of the design itself, I've got some initial materials that are available, basically some logs that I've milled down into lumber, and these are accurate sizes. So like I mentioned before, it's going to be about two floors, and hoping to do earth berms on the sides, at least two sides of the bottom, if I'm able to use an excavator later in the summer. And so this would be the top floor here, and it's basically just going to be a bunch of 2x4s and kind of a wooden area. So this dojo, it's only about 8 feet tall, these main posts. It's intentionally designed to be pretty modest, just enough to do my work. I am interested in integrating an automated storage and retrieval system, but it's sort of the same thing as with gardening, is there's all sorts of trade-offs that have to be done in the design process. The main thing that still is limiting to my design is to really confirm there's really maybe two things. One is starting on the core AI system with the orange crab. The idea behind that strategy would be to have the AI assisting me in the design and maintenance or fabrication of the dojo as I in parallel to my work, because it's available 24/7 to work on this, whereas I'm available maybe a few hours a day and on the weekends. So that's one idea, is to try and get an AI up and processing through this data as reasonably quickly and efficiently as I can. I'm pretty budget constrained, so I'm gonna have to be pretty smart on how I do this. I've got to keep myself alive before I keep the electricity running for an AI system or something like that. And then the other idea is to really focus on the vacuum insulated panel prototyping. So far I've made an example, like a test inner core, but there's lots of iterations and more precise measuring that could be done. The main thing is like testing how much strength it can withstand without losing form, whether it can withstand atmospheric pressure, and how porous is it really. Figuring out that and getting some countermeasures and more experiments ongoing there would be helpful. And then I guess the main risk of this project would not be the inner core but the membrane, as well as making a membrane to vacuum forming process.